Hello everyone. So in the previous video we were talking about so we've done a couple of exercises on slopes and linear equations, and we've actually done a few exercises um, on linear equations and solving those systems. Be it if we have more than a single, we have a system. So a system is basically a compound of um, more than one equation, and usually you have substitution as well as elimination. So these methods are suitable to solve such systems, and yeah, um, yeah. So we've actually stopped here. There was this chapter that we decided on doing, and then solve these exercises again. So it's still a continuation to the previous video on linear equations and solving the systems. We've done substitution in the last video, and we've done a couple of exercises on those. So to quickly recap, if the system has a single point, has a solution, then usually, basically, if it has a single solution, then usually there is a single point of intersection between the two lines. And if the result is actually the right hand side equals the left hand side, or 0 equals 0, then the system is actually has many solutions, and usually the lines are overlapping. If it's a 3D, then the space is overlapping. But if it's unlogical equation, or if you have the left hand side not equating the right hand side, then in this case you're basically saying that there is no solution whatsoever. Anyways, so there is this note here which is quite important, on that linear equations don't have really that specific form, but you just have to keep attention to the power. You see, usually there's no power of whatsoever. So if you get power of something, then you're basically out of the linear equation realm. Anyways, so this is linear equations is when you have two or more linear equations working together that we have seen. Now, if you solve this using elimination, then you add here, and then you would basically multiply the one at the bottom on -1. So this would be plus x minus y. So this would be eliminated, and then 3x would equal to 3, and then x would basically equate to 1. Okay, and there's this way of solving these problems using like, for example, there's this example where it tends to solve the problem. You have a literal problem, and they try to solve it using equations. So the process is quite straightforward, and in this case you can see that you can run 0.2 kilometers every minute. So you can run, so this is the speed and this is the time. For every minute you run 2.5 kilometers. Um, okay, the horse can run 0.5 kilometers for a minute, so that's something they share. They share the time, but it takes 6 minutes to saddle the horse. So this takes an extra 6 minutes to actually saddle the horse. Now, how far? So let's do, first of all, how far means how the distance. We know that the distance is the speed multiplied by time, correct? So the speed in this case is 0.2, and t is unknown. No, it's actually 1. So 0.2 multiplied by t, and then the horse can run 0.5 every minute. So that's 0.5 t plus 6. That's when you get the distance, right? 0.5 t minus, so we can make the equations, the distance t in kilometers and t in minutes. So you run 0.2 kilometers every minute, so d equals 0.2 every minute, right? 0.2, so how much have they traveled, right? How far? So that's the distance. Also 0.5, but we take off 6 of its time. Okay. So as you can see in the graph here, that this one starts from origin, but this one just starts 6 minutes later. At one point of time, do they really intersect? And then you could solve this by substitution. You could substitute one into the other. You could have 0.2t equals 0.5t minus 0.5 multiplied by 6 or 3. Okay. You know what a system of linear equations is? Let's continue to find out more about them. There can be many ways to solve linear equations. You could multiply this by -1, and then this would be plus, this would be minus, would be eliminated. So we have 4x equals 4, x would equal 1, x would equal 1, and y would equal 5. Where the two lines cross, well, we can't see where they cross, so it's already solved graphically. But now let's solve it using algebra. How to solve this? There can be many ways. In this case, both equations have y, so let's try to subtract the whole second equation from the first. Okay, so x equals 1, and the other one would equal to 6 minus 1 is 5. Okay, we substitute in. So all the simple variables are allowed in linear equations, so you really don't have these. So these are not really. Did we write this down? We should write it. We should have wrote this down because it's not linear. Okay. And we could like have this. We could have this done here. Not. So a linear equation can be in 2 dimensions, x and y, and there is a line that passes through, intersects the y-intersection. And then, or it could be 3-dimension, where we have a plane, right? You could have more than one dimension, of course. Okay. Z, x and y, and z. For equations to work together, they share one or more variables. A system of equations has 2 or more equations, or 1 or more variable. So a system of equations could have many equations and many variables. There can be any combination. Six equations in 4 variables, 9,000, yeah. When the number of equations is the same and the number of variables, there is likely to be a solution. Not guaranteed, but likely. When the number of equations is the same as the number of variables, there is likely to be a solution. Okay. In fact, there are only 3 possible cases. No solution, one solution, infinitely many solutions. Yeah. When there is no solution, the equations are called inconsistent. Usually this happens when they are parallel. One or infinitely many solutions, this usually happens when they have an intersecting point or when they are overlapping each other. Yeah. Independence and dependence. Independence means that each equation gives new information, Otherwise, they are dependent, also called linear independence and linear dependence. Okay, those equations are dependent. These equations are because they are likely they're really the same equation. And there's this method that we've learned about that we could easily determine if the slope is we really can't say for sure. Anyways, it really doesn't matter now, does it? Y would equal minus x, and this one minus 2. It's not the same slope, but if we multiply this by that, we could have the same slope. Really the same equation, just multiplied by 2. Yeah, when we multiply by 2, we have many solutions. Second equation gives us no new information. Okay, what are the equations? Where the equations are true? The trick is to find where all equations are true at the same time. What does that mean? U versus horse. The U line is true all along its length, but nowhere else. Anywhere on that line, d is equal to 0.2t. Okay, at t equals 5 and distance equal 1, the equation is true. Is d? Yes. At 5, the equation is not true. The horse line is always true along its length, but nowhere else. So what did it say? The trick to find where all equations are true at the same time. Okay, but on the point where they cross, are they both true? So they have to be true simultaneously. That is why people call them simultaneous linear equations. Okay, solve using algebra. This is the substitution method. Algebra to solve them. Here's the horse example, solved using algebra. In this case, it seems easier to set them equal to each other. So d equals 0.2, which equals 0.5 to much because it's the same d. So you could substitute this in there, and that's it. So it's the substitution method for you. You get the t, and then you apply it in any of the equations, you get the d. Algebra versus graphs. Why use algebra when graphs are so easy? Because more than two variables can be solved by a simple graph. So algebra comes to the rescue with two popular methods, solving by substitution and solving by elimination. By substitution, write the equation in its variable, replace and solve, repeat as necessary. Here's an example, two equations and variables. So what you could do is you could move the y to the other side and then you substitute the x. We start with any equation in a variable. Let's use the second equation and the variable y. It's 8 minus x. 8 minus x, and then you would 2 multiplied by 3 minus x. And then you solve accordingly, and then you just, yeah, we've known that, we've done that. So these solutions, because there is a solution, the equations are consistent. Yeah. Solving by substitution, 3 equations, 3 variables. We start with 2 and then do another 2. We should line up the variables neatly or we may lose track of what we're trying to do. We can start with any equation and any variable. Let's start the first equation and the variable x. Let's use the first equation and the variable x. Write one of them. Wait, we're still doing the substitution, not the elimination. So in this case, we could use anyone in any of the equations. Write in the equations, so it is in the style variable, okay? In the other equations, all of them. Luckily, there's only one other equation with an x. Otherwise, we should apply it to all of them. Solving using the usual algebra methods. Okay, 6, and then we simplify this and then simplify that. Good, we have made some progress, but there are yet. Now we repeat the process, but just for the last two equations. write one of the equations so it's in the style of variable. Okay. Place z with 3 minus y, which is here. So we've done this, we moved this to be z equals, so that would replace it here. Now we solve, so y equals minus 1, almost done. We can calculate z equals this, and that equals that, so yeah. And the answer is, please check it for yourself. We can use this method for 4 more equations and variables, just do the same steps again until it's solved. Works nicely, but does take a long time to do. It does indeed, especially if you grow more than 2 variables in the system, that it gets like super crazy. Can be faster, but needs to be kept neat. Eliminate means to remove. This method works by removing variables until there's just one left. The idea is that we can safely multiply an equation by a constant except for 0, add or subtract one equation onto another equation. So it's add or subtract, but preferably it would be an add. So we start off here to write it says minus, like in these examples. Okay, multiply by 2, so you'd get rid of these, and then you add these two together, so you'd have 2 z's. X minus, okay. Why can we add equations to each other? Imagine 2 really simple equations, right? So we can add the 5 to x minus x would equal to 8. If we add them together, x would equal to 8. Yep, this is just fine because both sides are equal, but it is what the equal is for anyway. Yeah. Okay. Can also swap equations around, so the first could come the second, etc. if that helps. Good time for example. Let's use the 2 equations in 2 variables. Example from before. Very important to keep things neat, so we know 3x plus 2y, x plus y equals 8. Yeah. And our aim is to do the elimination, so we multiply by -1. See that there is a 2y and a y. Let's work on that. Multiply the second equation by 2. Yes. Or minus 2. Minus 2x minus y equals -8. 16. Subtract the second equation from the first equation. Now we're left with, I know what x is. X equals 3. Now we see that the has 2x, so let's half it. Subtract. Wait a second. So when we do this, we've actually eliminated it. So that's a minus. That's 1x equals 3. Okay. Just substitute it here and then work our way. It's interesting. So in this case, we could multiply this by 3. So multiply that by 3. Then we do the addition. Or no, or we do the subtraction here, multiply by -1. Oh, this really doesn't solve the problem for us, so no solution. Both parallel. If we multiply this by negative 3. So -6x plus 3y, so equals 0, 0, many solutions. Solving by elimination, 3 equations, 3 variables. Eliminate x's first from the equation 2 and 3 in order. Okay, eliminate x's, then eliminate the y from equation 3. Then we'll have a triangle. Now start at the bottom and work your way back up. Back substitution. Resolved. Okay. So we will find it easier to do some calculations in our head rather than always working within this set of equations. We write them neatly like he's doing it here. Then we eliminate the x from the second equation. Third equation, there is no x in the second equation. With the third equation, subtract 2. First one. It's an interesting way of solving these problems, but yeah. As you get used to the elimination method, it becomes easier than substitution because you just follow the steps and the answers appear. But sometimes it can give you a quicker result. For small cases like 2 equations or sometimes 3 equations, elimination is easier. For larger cases, and it always pays to look over the equations first to see if there's an easy shortcut, so experience helps. Alright. It's interesting that these guys have a different way of solving these problems, and it's not that these problems are actually complicated or anything, but it's more like, they have a different way of solving them is all. So if we can go for these 2 equations, so we have 2x. Alright, I have a pen and paper, so that's why you probably hear the paper noise. 2x plus 5y would equal to 21. Right, and the second equation is x plus y equals 3. So what's the question? Then what is the value of x? So what I could do, he didn't really specify if it's substitution or elimination, so let me solve it my own way. So I'll multiply the second equation by -2. That would be like -2x minus 2y minus 6. So I'm going to solve for this accordingly. So we add these 2 equations together. We have eliminated the x. So 5 minus 2, that's like 3y, would equal to 21. 21 minus 6. 21 minus 6, that's like 25, right? 15. Yeah, hopefully it's 15. I hope I'm not mistaken on that one. So I'll go 15. So y would equal to 15 over 3. That's like 5, right? And then what we would do is that we take the y and apply it anywhere in the equations. Let's apply it on the second equation, which is x plus y equals to 3. So x plus 5 would equal to 3. You take on, so x would equal to minus 2. So we have x equals equating to minus 2, and that is correct. So it's done the substitution method. It could have been faster, I don't know, but anyways, we got the same results. Next question. Let's start with this again. So we have 7x plus 2y equals to 3. Then we have x minus 3y equals to 30. What is the value of y? Now we could go for substitution in this case. Well, let's do that, right? Let's have 3y, negative 3y. Let's do things slowly so that we really don't miss anything. 30 minus x. If we divide this by 3, well, I don't think we should go for substitution. We don't want to deal with fractions. It's easier just to, so let's get rid of the x's. So we multiply the second equation by -7. So we will have -7x plus 21y, and then 30 multiplied by 7, that's like 221, 210. Yeah. So we have this equation, right? And then we do the addition. So we have minus 7x minus plus 21y equal. So we eliminate the x's. So we will have 23y would equal to 213. So y would equal 213 out of 23. I'm not sure if this has a solution. If we divide it by 23, if we divide it by 23, what's the common? We have the 3. It's not really. Is this 23 a prime number? I don't know. Anyway, so y is 213 over 23. Right. Oh, probably have done something wrong. We know the equation is x minus 3y equals to 30. Right? Yeah. So if we multiply it by 7, multiplied by minus 7, negative 7. So we'll have negative 7x minus plus, we have that 7 plus 21, 21y equal to 110. What's wrong? Negative 210. It's negative 210. So let's organize things here. So the x will be eliminated. So we have 2y equals to 3. And the second equation would be 21y equals negative 210. Now we have these two equations. So y would equal to negative 210 divided by 21. It's like 10. We get a negative 10. Like, what is wrong? Why aren't we getting a proper result here? Of course, I'm really doing a terrible thing here. I've really messed up things here. Let me re-solve this problem again. So let's do it properly. So we have 7x plus 2y equals to 3. And then the second equation is negative 7x plus 21y equals to negative 210, right? So let's do the addition. Now the x's will be eliminated. We will have 23y equals to negative 113. So y would equal to 213 minus 213 over 23. Then what's the problem? What are we doing wrong? That's not 213, that's actually 207. Sorry, 207. Is this a solution? Let me get a calculator. Try to see. But wait a second, could this be 9? Negative 9? Yeah, it should be to negative 9. Oh my god. That was rather easy, but for us to really miss on the numbers, it's pretty nasty. Okay, let me flip my paper and solve again for another problem. So we have 2x plus 5y would equal to negative 1, and then the second equation is 3x minus 2y equals to 27. Okay, so I've been using the elimination for a pretty good time now. I think I keep at it because it seems to be simpler approach to. Now this might be a little tricky because we need to multiply both equations by a number to be able to eliminate one. Or we could opt for a substitution, if that's a good option to us. Let's go for, let's try substitution today. Sorry, this time. So x would equal to 2y plus 27 divided by 3. So we will have x would equal to 2y over 3 plus 27 over 3. We have a 9 here. Okay, so let's do the substitution then. So so this is the second equation. Let's substitute in the first equation. So 2x and then 2 multiplied by 2y over 3 plus 9 plus 5y would equal to -1. And then we have 4, multiply the 2 by the numbers on the brackets, then we have 4y over 3 plus 18 plus 5y equals -1. And then when we do the unification of denominator, we have 4y plus 5y, sorry, not plus 5, that's 15. 15, sorry, we need to, yeah, so we have 4y plus 15y over 3 plus, so take the 18 to the other side, then we'll get -19. And now we would be 19y over 3 would equal to -19. Now we multiply by 2/3, by 3. So 19y would equal to -19 multiplied by 3. 19 multiplied by 3, that's like -57. Then y would equal -57 divided by 19. But they're asking for the value of x, which is like surprisingly then we have, okay, so y is like, y would equal -3. This should be like easy to substitute one on the other. So we have, let's try to, so we have -3. So we have 2y, 2 multiplied by -3 over 3. You have 2, -2 plus 9. X would equal to 6, 7. Yeah, x would equal to 7. Oh, great. Now, when I use the elimination, when I use the substitution, they've used the elimination. Oh boy, oh boy, oh boy. But anyways, this is rather interesting for us, isn't it? Okay, so on with the next one. I think we could safely say that we have a good understanding of how this really works. So we have 4x minus 3y, which equals to -18. And then we have the second equation, 6x minus plus 7y, that equals to -4. However, try to solve these equations, I'm looking at them just like to have a quick glance on these. We could multiply, which one would be better to eliminate? Let's eliminate the y, okay? So the first one will be multiplied by 7, and the second one will be multiplied by 3. So we have the first one. So let's do the first one, multiply the first one by 7. So start with that. So 4 multiplied by 7. So we have 28 x minus 21 y, which equals to, no, 18 multiplied by 7 is like 126, -126, and the second one by 8, we have 18x plus 21y equals to, we have 4 multiplied by 3, that's -12, right? Now let's do this. We eliminate the y. We will be left with 28, 18, so we have 16, 3, 4. We We have 46x equals to, so you plus negative plus, so that's like 8, 3, 138, negative 138. So x would equal negative 138 divided by 46. You know, we could have eliminated the x because they're looking for the y. It's been easier for us. But, you know, whatever. So let's do this. 138 divided by 46, that's negative 3. And then we have x equals negative 3. So they are looking for the y. So the y, let's substitute this. So we have 4x. So negative 12. That's negative 12. Minus 3y, which equals negative 18, right? So we take the 12 to the other side. It's negative 3y. It equals to negative 4. Sorry, negative 6. And then we get rid of the negative 3. So y would actually be 2. Awesome. Fantastic. So they've done they took the shortcuts in which they've replaced the first one, the first equation, and got rid of the second one. And yeah, I mean, we could have done the same, but we just took whatever approach. We didn't pay attention to what the question was actually asking us to do. What is the value of x minus y? Okay, they're asking us the tough questions now, eh? Let's try to quickly get this over with. And then we could stop here. We could do this question and we could stop here. We have 2x minus 3y would equal to 24. And then for the second equation, we have 3x plus 4y, which equals to 2, right? And then what we need to do is we need to get the value of x. Now, we could eliminate any one of them, but, you know, we could multiply the first equation by 3 and the second equation by 2. I'm eliminating the x. It really doesn't matter. So let's do that. So we have 6x minus 9y, which equals to then 24 multiplied by 3. That's like 72, right? And then for the second equation, we have 6x plus 8y equals to 4. Now the x's are, oops. Let's do this minus the second equation be multiplied by minus 2 then. Minus 4. So the x's are eliminated. So we have minus 17y, which equals to 68. Okay, so y equals 68 divided by 17. That's like 4. This is negative 4. So y is negative 4, right? Because we have that. And then we take this one and multiply it in the first equation. So we have 2x minus, so it would be plus 12 equals 24. So we take the 12 to the other side. It would be like 24 minus 12. So 2x would actually equal 12, and then x would equal 6. So x minus y, so it's 6 minus 4, 6 plus 4 is 10. The value is 10. Voila. Good job, Brim. Okay, so I'm going to finish this the rest of the equations on my own, and I'll stop recording now because I'm about out of charge. Anyways, so I'm going to find a place to plug in, and I'm going to finish the rest of the exercises. But it's pretty nice. I like this site because it really gives you more ways of solving this problem. Anyway, so I like this site because it has this set of exercises, and it's not really, you know, straightforward kind of exercises. They have scare you with the big numbers, but eventually you'll end up with small numbers. Anyway, so in our solution, we've multiplied the first one by 3 and the second one by negative 2. In his case, he opted to get rid of the y, and ultimately we both get the same result. So y is actually negative 4, And in our case, we've actually got y to be -4 and x to be 6, and that's exactly what we've got here. So either way, this is the beauty of maths. Either equations actually works. It's pretty neat. Anyways, so see you on the next video. So this video was more exercises on linear equations and solving linear equations by elimination and substitution. Until the next video, have a good one.